Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
1923 Bertrand Russell, Alfred Whitehead Principia Mathematica. The early 20th century witnessed an ambitious intellectual quest for certainty, a foundationalist impulse, and sought to secure the edifice of human knowledge upon an unshakable bedrock. Within this fervent climate, the magnum opus of Bertrand Russell and Alfred Whitehead, Principia Mathematica, stands as a monumental testament to this aspiration. The work, culminating in its second edition of 1923, proposed a breathtakingly audacious thesis that all the truths of mathematics could be derived from a spare collection of purely logical concepts and axioms. This essay undertakes a direct and internal evaluation of the central claims, mechanisms, and arguments presented within the Principia, proceeding systematically through its core components. The objective is to assess the logical machinery on its own terms, examining the coherence and ultimate success of its grand logicist project as articulated from within the text itself. It is an exploration of a cathedral of reason, built to house mathematics, whose internal architecture reveals as much about the limits of logic as it does about its Section 1. The primitive ideas and axiomatic foundation. The Principia Mathematica commences its vast undertaking with a sparse collection of primitive ideas and propositions, the ostentable bedrock upon which the entire structure of arithmetic and analysis will be constructed. The central claim here is one of sufficiency and intuitive clarity, that these elementary components, requiring no prior definition within the system, provide a complete and secure starting point for all subsequent deductions. The authors introduce concepts such as the elementary proposition, the function of assertion, and logical connectives like negation and disjunction. The famous assertion sign, a vertical bar preceding a horizontal one, becomes the work's primary operator, denoting that what follows is a proven truth of the system. The primitive propositions themselves are presented as fundamental tautologies, such as the principle of tautology, which states that a proposition or a proposition implies that proposition, and the principle of addition, stating that P implies the disjunction of P or Q. The evaluation of this foundational section hinges on the success of its claimed self-evidence and completeness. The system's power derives from its minimalism, the sheer intellectual leverage it purports to gain from such a slender base. The internal argument is that these axioms are the very laws of thought, universal and undeniable. A critical examination reveals their function as formal rules for symbol manipulation. Their intuitive appeal, while present, is subordinate to their operational role within the deductive apparatus. The claim of sufficiency is what the subsequent volumes must vindicate. The foundation is laid with a deliberate and austere precision, positing that from these few logical seeds, the entire forest of mathematics will grow. The validity of this initial claim is therefore deferred, becoming a promissory note that the remainder of the work is dedicated to caching. Section 2, the ramified theory of types. In the next major section, Russell and Whitehead introduce the conceptual centerpiece of their system, the ramified theory of types. This intricate hierarchical framework is the Principia's direct answer to the logical paradoxes, particularly Russell's own, that threatened to collapse the foundations of set theory and logic. The theory's primary claim is that it can systematically prevent the formation of illegitimate, self-referential totalities, thereby restoring consistency. The mechanism for this is a strict stratification of all entities individuals, classes, and propositions into a hierarchy of types. An individual is of type 0, a class of individuals is of type 1, a class of classes of individuals is of type 2, and so forth. A statement about a collection of objects is always of a higher type than the objects themselves. This structure successfully prohibits a class from being a member of itself, dissolving the paradox at its root. The theory is further ramified by introducing orders, which stratify propositional functions based on the logical complexity of their quantifiers. A critical evaluation of this claim to resolve the paradoxes must acknowledge its effectiveness. The theory does, as a matter of formal procedure, block the specific contradictions that motivated it, yet its internal justification presents considerable difficulties. The complexity of the hierarchy feels architecturally imposed, an elaborate scaffold erected to repair a deep fissure in the logical firmament. Its claim to being a natural feature of logic is strained. The theory introduces a labyrinthine set of formation rules that govern what constitutes a meaningful proposition. This machinery, while successful in its prophylactic purpose, imbues the system with a character of artificiality, suggesting that the laws of thought are perhaps more baroque and less intuitive than the project's foundationalist aims would prefer. The solution works, but its aesthetic and philosophical cost is immense, a complexity that hints at the deep difficulties inherent in formalizing language about language. Section 3. The axiom of reducibility. The very complexity of the ramified theory of types created a severe internal problem, which necessitated the introduction of another, more controversial, axiom, the axiom of reducibility. The strict hierarchy of orders, while preventing paradoxes, also rendered much of classical mathematics impossible to derive. For example, the principle of mathematical induction and the definition of real numbers require propositions that quantify over properties, an action restricted by the ramified structure. The axiom of reducibility claims that for any propositional function, there exists a formally equivalent predicative function, which is a function of the lowest possible order. The effect of this axiom is to collapse the intricate hierarchy of orders, restoring the expressive power needed for mathematics, while attaining the paradox-blocking hierarchy of types. In evaluating this claim, one confronts the most significant point of philosophical tension within the Principia. The axiom effectively asserts the existence of certain logical entities without providing any method for their construction. Russell himself, in later writings and in the introduction to the second edition, expressed profound reservations about its status. Unlike the other axioms, it lacks any pretense of being a self-evident logical truth. It appears to be an empirical hypothesis about the richness of the logical universe. Its inclusion is a pragmatic concession, a powerful tool required to make the system work, but one that deeply compromises the project's logicist thesis. The claim that mathematics is pure logic is substantially weakened by the need for an axiom that seems to state a fact about the world of concepts. Critics like Ramsay and Wittgenstein would later identify this axiom as the point where the Principia's claim to a priori certainty falters, revealing it less as a discovery of logic and more as an invention for Section 4. The definition of number and the construction of arithmetic. With the controversial axioms in place, the Principia proceeds to what is arguably its most celebrated achievement, the derivation of the natural numbers and the principles of arithmetic. The central claim of this part of the work is that numbers are sophisticated logical constructions, specifically classes of equinumerous classes. The mechanism for this is ingenious and foundational to the logicist program. The number 2, for example, is defined as the class of all pairs. The number 1 is the class of all classes containing a single member. The number 0 is defined as the class whose only member is the empty class. From these definitions, Russell and Whitehead painstakingly derive the properties of numbers and the operations of arithmetic. Addition is defined in terms of the logical sum of two mutually exclusive classes. The entire apparatus of Peano's postulates, the axiomatic basis for arithmetic, is shown to be derivable within their system. The evaluation of this section must recognize its monumental technical success. It demonstrates, with exhaustive rigor, how the familiar world of arithmetic can emerge from a purely logical substrate. The famously laborious demonstration, deep within the first volume at proposition *54.43, that 1 + 1 = 2, serves as a dramatic, if somewhat droll, proof of concept The derivation validates the claim that numbers need have no mysterious, Platonic existence. They can be constructed, however. The triumph is conditional. The entire magnificent construction rests upon the shaky pillars of the theory of types and the axioms of reducibility and infinity. The derivation is logically valid, but its premises carry the philosophical baggage discussed previously. The claim that arithmetic is logic is thus proven, but only a particular, and highly contentious, version of law. Section 5. The axiom of infinity and the problem of existence. To progress from finite arithmetic to the mathematics of the infinite, which underpins calculus and most of modern analysis, Russell and Whitehead had to introduce another critical, and explicitly hypothetical, premise: the axiom of infinity. This axiom asserts the existence of at least one class containing a countably infinite number of individuals. The central claim here is more of a concession the authors present this axiom, labelled in Finax, as a necessary hypothesis for the development of higher mathematics, acknowledging its distinct status from the more fundamental logical axioms. Its inclusion is an admission that the existence of an infinite collection of objects cannot be guaranteed by logic alone. A critical evaluation of this claim reveals another profound limit to the logicist project. The question of whether the universe contains an infinite number of discernible individuals is an empirical one, a matter of cosmology or physics, an issue entirely outside the a priori domain of logic. By making the bulk of classical mathematics contingent upon this hypothesis, the Principia effectively demonstrates, if logic alone is insufficient to generate mathematics in its entirety, it can provide the structure and the rules of inference, but it cannot guarantee the existence of the objects that mathematics describes. The internal argument of the book is thus forced into a conditional form. If the universe is infinite, then the truths of classical analysis follow as theorems of logic. This is a far more modest claim than the original ambition to ground all of mathematics in absolute, a priori certainty. It shows that at the boundary of the infinite, logic must appeal to a postulate about the nature of reality, thereby surrendering its claim to complete autonomy. Section 6. The second edition revisions and their implications. The 1923 second edition of the Principia is notable for its extensive new introduction and 3 appendices, in which Russell, heavily influenced by his student Ludwig Wittgenstein, re-evaluates the work's core tenets. The claims made in this new material amount to a profound self-critique. Russell attempts to address the system's most significant weakness, its reliance on the axiom of reducibility. The proposed new mechanism involves abandoning the axiom in favor of a purely extensional view of functions, where a function is defined solely by its values. The hope was that this new approach, which treated propositional functions as logical fictions, would make the ramified hierarchy of orders unnecessary, thus obviating the need for reducibility. An evaluation of this attempted revision reveals the deep and persistent nature of the problems. The new machinery, while philosophically leaner, proved to be technically inadequate. It failed to recover crucial parts of mathematics, most notably the principle of mathematical induction, which remained out of reach without the powerful axiom it was designed to replace. The very existence of this revised introduction serves as the most potent internal critique of the original edition's claims to finality. It demonstrates that Russell himself recognized the philosophical untenability of the axiom of reducibility and the artificiality it introduced. The failure of the proposed alternative underscores the profound difficulty of the enterprise. The Principia, in its second edition, becomes a document not only of a grand synthesis but also of its own partial unravelling, a testament to its author's intellectual honesty in confronting the deep aporias their own creation had revealed. The revisions show that the magnificent logical engine, once constructed, was found to have deep and perhaps irreparable structural flaws. In conclusion, a direct evaluation of the claims advanced within Principia Mathematica reveals a work of dual character. On one hand, it is a technical masterpiece, a landmark of formal logic that succeeded in demonstrating a pathway for deriving the vast complexities of mathematics from a defined logical base. Its development of a full language and deductive system was revolutionary, shaping the course of analytic philosophy, logic, and computer science for the century to follow. On the other hand, the work falls short of its ultimate philosophical ambition, the logicist thesis. The claim that mathematics is nothing more than developed logic is significantly compromised by the very machinery required for its execution. The contrived complexity of the theory of types, the dubiously non-logical character of the axiom of reducibility, and the explicitly empirical nature of the axiom of infinity collectively demonstrate that the foundations of mathematics are intertwined with assumptions that extend beyond the purely formal and a priori. The Principia did not, in the end, ground mathematics in unshakable logical certainty. Instead, its monumental effort and its celebrated shortcomings illuminated the profound philosophical questions that lie at the very heart of reason itself. It remains an essential work, less for the answers it provides, and more for the clarity and depth of the problems it so rigorously and unforgettably exposed. Its failure was, in many ways, more intellectually fruitful than any simple success could ever have been.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.